हेलो डियर स्टूडेंट, वेलकम टू एनसीईआरटी रीडर। तो इस वीडियो में आप ये देखेंगे कि हम लोग डिस्कस करने जा रहे हैं ऑसिलेशंस एंड वेव चैप्टर को, जो कि काफी इंपॉर्टेंट चैप्टर है फॉर द पॉइंट ऑफ व्यू जेईई मेन एंड एडवांस। अगर हम ऑसिलेशन की बात करें तो ऑसिलेशन एक ऐसा चैप्टर है जिसमें एसएचएम के क्वेश्चंस जो है आपको इलेक्ट्रोस्टैट में भी बिल्ड होगा। दिस इज पर्टिकुलर काइंड ऑफ चैप्टर ऑफ क्लास 11। फिर आपको इलेक्ट्रोमैग्नेटिक इंडक्शन अगर आप पढ़ेंगे उस केस में भी एसएचएम यूज होगा आपको। तो कुल मिलाकर के पूरे क्लास 12 में मेजर चैप्टर्स में ऑसिलेशन एसएचएम, जहाँ पे भी फ्रीक्वेंसी टाइम पीरियड की बात आएगी तो वो काफी इंपॉर्टेंट होगा, जिसको कि आप ऑसिलेशंस में ही सीख सकते हैं और इसके कंसेप्ट को वहां पे इन्फ्यूज किया जाएगा। जे एडवांस क्वेश्चन का मतलब ही है कि क्वेश्चन जो है आपको किसी एक चैप्टर का डायरेक्ट नहीं पूछा जाएगा। इट विल बी कंसेप्ट ऑफ अदर चैप्टर आल्सो, एंड मिक्स अप काइंड ऑफ क्वेश्चन विल बी देयर टू मेक द क्वेश्चन लेवल डिफिकल्टी। तो ये चीज ध्यान रखेंगे। और दूसरा जो इसमें चैप्टर है वो वेव है। तो कुल मिलाकर के इस वीडियो को देखने से आपका दो क्वेश्चन जेईई मेन के लिए 100% श्योर हो जाएगा, अगर आप वीडियो को कंप्लीट समझ लेते हैं। तो जेईई मेन में क्वेश्चन जस्ट फॉर्मूला बेस्ड ही आएगा, जो कि आसानी से आप बना सकते हैं। अगर आप किसी भी ईयर के क्वेश्चंस को देखोगे जेईई मेन का, तो इट इज जस्ट फॉर्मूला बेस्ड काइंड ऑफ क्वेश्चन ओनली दे आस्क। लेकिन जेईई एडवांस के लिए आपको थोड़ा डीप एनालिसिस करना होगा, और जो अंडरस्टैंडिंग लेवल है उस पे आपको विजुअलाइजेशन लेवल पे जाना होगा। कुल मिलाकर के ये चैप्टर जो है क्विक रिवीजन होगा, रैपिड रिवीजन टाइप का होगा। इसमें हमेशा ये चीज ध्यान रखेंगे कि हम मेजर डेरिवेशंस पे नहीं जाएंगे, थोड़ा शॉर्ट में रखेंगे, सो दैट कि इट विल सेव योर टाइम एंड यू कैन रिवाइज द टू कंबाइंड चैप्टर इन जस्ट 1 आवर ऑलमोस्ट इट विल बी। सो लेट्स सी दिस दैट व्हाट आई एम गोइंग टू डू। एक एक करके हम लोग सारा कंसेप्ट को देखते हैं, और जो इसमें आपका थ्योरी एंड जो कंसेप्ट बिल्ड होगा वो चीज आपके माइंड में बैठ जाना चाहिए, देन ओनली यू कैन सॉल्व द क्वेश्चन ऑफ जेईई मेन। सो यहाँ पे जो फर्स्ट कंसेप्ट बिल्ड करने के लिए आपका दिया गया है जेईई मेन में, वो है पीरियडिक फंक्शन। पीरियडिक फंक्शन किसको बोलेंगे? सॉरी, पीरियडिक मोशन। In mathematics, you have learned the periodic function, that kind of function which repeats itself after some time, after some in regular interval of time, that is called period of the function. It is called periodic motion. जैसे अगर मोशन की बात करें तो मोशन जो कि रिपीट करे इटसेल्फ एक पर्टिकुलर इंटरवल ऑफ टाइम के बाद, उसको हम लोग बोलेंगे पीरियडिक फंक्शन। तो जो मोशन रिपीट करे अपने आप को पर्टिकुलर टाइम इंटरवल के बाद, उसको बोलेंगे पीरियडिक मोशन। द मोशन which repeat itself after a fixed interval of time, fixed interval of time। जैसे हम बात करते हैं कि अगर आप मोशन को सन के मोशन को करते हैं, अर्थ के मोशन को देखते हैं, सॉरी अर्थ के मोशन को अगर हम बात करें तो मोशन ऑफ अर्थ, अर्थ मोशन अराउंड सन। तो हम जान रहे हैं कि अर्थ जो है सन के चारों तरफ जो है रिवॉल्व कर रहा है, और जो पूरा कंप्लीट एक कंप्लीट ईयर में इसको सन के चारों तरफ एक चक्कर काट रहा है। अपने एक्सिस पे अगर हम देखें अर्थ को, तो 24 आवर्स में वो रोटेट करता है और रिवॉल्व करता है सन के चारों तरफ 1 ईयर में। तो ये जो टाइम एक इंटरवल है आपका फिक्स्ड जो अर्थ का है, इसको पीरियडिक मोशन बोला जाएगा। नेक्स्ट वी हैव ऑसिलेटरी मोशन। ऑसिलेटरी मोशन का मतलब ये है कि जो भी मोशन टू एंड फ्रो काइंड ऑफ मोशन होगा, उसको हम लोग जैसे बैक एंड फोर्थ टाइप का मोशन जो भी होगा, तो टू एंड फ्रो टाइप का जो भी मोशन होगा, टू एंड फ्रो, या इसी को हम लोग बोलेंगे बैक एंड फोर्थ। तो जब भी बैक एंड फोर्थ या टू एंड फ्रो काइंड ऑफ मोशन होगा जो कि सेम पाथ को पीरियडिकली फॉलो करेगा, सेम पाथ को पीरियडिकली फॉलो करेगा। जैसे अगर हम बात करते हैं कि ऑसिलेटरी मोशन को ही हम लोग वाइब्रेटरी मोशन भी बोलते हैं। इट्स काइंड ऑफ वाइब्रेटरी मोशन, इट्स वाइब्रेटरी मोशन ओनली, और ऑसिलेटरी मोशन यू कैन से। तो जो भी मोशन फिक्स पाथ को एक पीरियड के बाद टू एंड फ्रो मोशन करेगा, दैट काइंड ऑफ मोशन वी कैन से ऑसिलेटरी मोशन। एज फॉर एग्जांपल इट इज मोशन ऑफ पेंडुलम। मोशन ऑफ पेंडुलम, पेंडुलम को आपने देखा ही होगा। तो पेंडुलम के केस में आप ये चीज देखे होंगे कि ये पेंडुलम जो है वो एक रेगुलर इंटरवल के बाद जो है टू एंड फ्रो मोशन करेगा, इधर जाएगा फिर इधर आएगा। तो इस तरह का जो मोशन होगा एक पाथ को फॉलो करते हुए सेम with the same what you can say periodically it will be, that is called oscillatory motion. So what you can say about oscillatory motion and the periodic motion is जो भी oscillatory motion होगा क्या वो periodic होगा? बिल्कुल होगा। लेकिन क्या जो periodic motion होगा वो oscillatory होगा? बिल्कुल नहीं होगा। तो इसीलिए हम ये चीज बोल सकते हैं कि जो भी oscillatory motion होगा, जो भी oscillatory motion होगा, it must be periodic, must। लेकिन जो periodic motion होगा ये कोई जरूरी नहीं है कि ऑसिलेटरी हो जाए, कोई जरूरी नहीं। तो यहाँ पे हम मे नॉट लिखें, मे और मे नॉट, मे और मे नॉट। तो दैट मीन्स यू नीड टू अंडरस्टैंड, जैसे अभी आपने देखा था कि जो एग्जांपल हमने लिया था अर्थ का, तो अर्थ सन के चारों तरफ जो है टू एंड फ्रो मोशन नहीं कर रहा है, वो पीरियडिक मोशन। लेकिन टू एंड फ्रो मोशन जो भी है वो जो है ऑसिलेटरी मोशन है, और जो भी ऑसिलेटरी मोशन होगा वो पीरियडिक मोशन होगा, दैट्स इट। तो ये चीज आपके दिमाग में रहना चाहिए। नेक्स्ट वी हैव पीरियडिक मोशन। द फर्स्ट फंक्शन व्हाट आई सेड यू पीरियडिक मोशन ओनली, बट पीरियडिक मोशन को अगर हम लिखना चाहें तो इसको कैसे लिखेंगे मैथमेटिकली? पीरियडिक मोशन mathematically, how you can write the periodic motion? Let's suppose I am considering any function over there f, and ये जनरल टाइम है और इसमें एक टाइम t को जोड़ रहे हैं। अगर ये फंक्शन t के बराबर ही हो जाए, इस तरह का अगर हो जाए, तो दैट मीन्स कि इस तरह में हम लोग ये बोलेंगे कि ये जो फंक्शन है आपका, ये फंक्शन पीरियडिक। सो दिस फंक्शन इज कॉल्ड पीरियडिक, f इज हियर पीरियडिक, एंड इसका पीरियड क्या है? एंड t इज द पीरियड ऑफ दैट फंक्शन। तो टी इंटरवल के बाद जो है ये फंक्शन रिपीट हो रहा है। जैसे आप जानते हैं कि y इज इक्वल टू, अगर हम साइन x की बात करें तो साइनोसोइडल फंक्शन है, इसका पीरियड क्या होगा? x में हम कितना जोड़ेंगे कि फिर से वही फंक्शन आ जाए? तो आप जान रहे हैं कि अगर हम x में 2 पाई जोड़ दें तो ये फंक्शन फिर से साइन ही बन जाएगा। तो दैट मीन्स कि 2 पाई इज द पीरियड आफ्टर विच द फंक्शन यू आर गेटिंग द सेम इट इज, दैट इज कॉल्ड इट इज पीरियडिक motion kind of function it is. So periodic motion I have written here, it should be periodic function. तो पीरियडिक फंक्शन को समझने के लिए आपको ये चीज ध्यान रखना है कि मैथमेटिकली अगर हम इसको देखें तो कोई भी फंक्शन में अगर हम एक रेगुलर इंटरवल टाइम को अगर जोड़ते हैं और अगर वही फंक्शन फिर से आ जाता है, दैट इज कॉल्ड पीरियडिक मोशन। नेक्स्ट वी हैव हार्मोनिक मोशन। हार्मोनिक मोशन, हार्मोनिक मोशन का मतलब होता है कि जब भी कोई ऑसिलेटरी मोशन पार्टिकल का अगर कोसाइन फॉर्मेट में या साइन फॉर्मेट में हम लिख पाए उसको, यानी कि साइन या कोसाइन फॉर्मेट में अगर हम लिख पाए किस मोशन को? ऑसिलेटरी मोशन को। तो उस मोशन को हम लोग बोलेंगे हार्मोनिक मोशन। तो जब भी आप ऑसिलेटरी मोशन को, व्हेन एन ऑसिलेटरी मोशन ऑफ ए पार्टिकल can be expressed in terms of साइन और कोसाइन फंक्शन। जब भी साइन और कोसाइन फंक्शंस के फॉर्मेट में आप इसको लिख पाते हैं तो इसको बोला जाएगा इट इज सेड टू बी अ हार्मोनिक मोशन। तो दैट मीन्स कि हार्मोनिक मोशन होने के लिए क्या होना जरूरी है? ऑसिलेटरी। और ऑसिलेटरी मोशन का साइन और कोसाइन फॉर्मेट होना जरूरी है, तभी वो हार्मोनिक होगा। तो साइन और कोसाइन ऑसिलेटरी, एंड दैट विल बी कॉल्ड हार्मोनिक मोशन। दिस इज द थिंग यू हैव टू रिमेंबर, कीप इन माइंड। नेक्स्ट, अब हार्मोनिक तक तो ठीक है, यानी कि आपने कितने तरह का मोशन देखा? पहला पीरियडिक, फिर ऑसिलेटरी या वाइब्रेटरी, फिर पीरियडिक फंक्शन हमने देखा, फिर हार्मोनिक। अब सिंपल हार्मोनिक जो कि इस चैप्टर का रीड है, सिंपल हार्मोनिक। सिंपल हार्मोनिक मोशन क्या है? सिंपल हार्मोनिक मोशन। तो कोई भी मोशन को अगर आप साइन या कोसाइन फॉर्मेट में अगर हम लिख पाते हैं तो वो हार्मोनिक मोशन है। यानी कि अगर हार्मोनिक फंक्शन अगर हो या हार्मोनिक मोशन अगर हो, वो सिंपल हार्मोनिक कब होगा? यानी हार्मोनिक मोशन कैन बी सिंपल हार्मोनिक मोशन। कब होगा ये सिंपल हार्मोनिक हार्मोनिक? तो ये तब होगा जिस समय इसमें आपको फोर्स जो होना चाहिए वो डायरेक्टली प्रोपोर्शनल टू निगेटिव ऑफ द डिस्प्लेसमेंट होना चाहिए। दिस इज द कंडीशन दैट कि जो भी पार्टिकल पे आप जिस पार्टिकल पे आप एनालाइज कर रहे हो कि ये हार्मोनिक मोशन है और वो सिंपल हार्मोनिक में वो बन जाए, तो जब भी मोशन को एक्सप्रेस किया जाता है साइन ऑसिलेटरी मोशन को साइन फंक्शन में या कोसाइन फंक्शन में, तब वो हार्मोनिक होगा। और हार्मोनिक होने के बाद मोशन को हम सिंपल हार्मोनिक कब बोलेंगे? तो दैट मीन्स कि जब भी मोशन को हम एक्सप्रेस करते हैं साइनसोइडल में या कोसाइन फंक्शन में, उस केस में आपको ऐसा मिल जाएगा कि फोर्स जो होगा वो डिस्प्लेसमेंट के प्रोपोर्शनेट होगा। दैट मीन्स कि हार्मोनिक मोशन will be simple harmonic format. In that case we'll be having, this is the condition that force is directly proportional to negative of the displacement. सो दैट इसको अगर हम लिखना चाहे प्रोपोर्शनैलिटी टर्म को हटा के, तो हम कैसे लिख सकते हैं? दैट मीन्स फोर्स इज इक्वल टू माइनस ऑफ के एक्स। यहाँ पे के क्या है? के कांस्टेंट है। और इस फोर्स में माइनस साइन का मतलब ये है कि जिधर डिस्प्लेसमेंट हो रहा है उसके अपोजिट डायरेक्शन में ये फोर्स लग रहा है। दैट इज व्हाई माइनस साइन हियर इट इज। तो इस फोर्स को हम लोग बोलते हैं रीस्टोरिंग फोर्स। रीस्टोरिंग फोर्स इसको बोलेंगे। स्प्रिंग काइंड ऑफ फोर्स, स्प्रिंग फोर्स में आपने देखा होगा कि अगर स्प्रिंग को आप इलोंगेट करोगे तो स्प्रिंग उसके अपोजिट डायरेक्शन में एक फोर्स लगाएगा, जिसको हम लोग रिस्टोरिंग फोर्स बोलते हैं। और इसीलिए यहाँ पे ये जो आपका माइनस साइन आया है कि फोर्स जिधर लग रहा है और जिधर ये डिफॉर्मेशन हो रहा है यानी कि डिस्प्लेसमेंट हो रहा है वो अपोजिट डायरेक्शन में। अब इसी का अगर हम एक्सलेशन फॉर्मेट में लिखना चाहें तो दिस इज माइनस ऑफ के बाय दिस फोर्स को हम लोग एम ए लिखते हैं। तो एम ए इस फॉर्मेट पे हम लोग इसको लिख सकते हैं। और यहां से आपको एक्सलेशन जो है इस फॉर्मेट में आ रहा है। एक्सलेशन को हम कैसे लिखते हैं? डबल डिफरेंशिएशन ऑफ एक्स बाय डी टी स्क्वायर और दिस इज इक्वल टू माइनस ऑफ के बाय एम टाइम्स ऑफ एक्स। और इस इक्वेशन को आप फिर से इस तरीके से लिख सकते हैं, डी टू एक्स बाई डी टी स्क्वायर एंड देन प्लस के बाय एम टाइम्स ऑफ एक्स इज इक्वल टू जीरो। इस के बाय एम को हम यहाँ से एक टर्म से रिप्लेस करते हैं एंड दैट इज कॉल्ड ओमेगा स्क्वायर। तो फाइनल जो रिजल्ट हमारे पास आ रहा है डी टू एक्स बाय डी टी स्क्वायर प्लस ओमेगा स्क्वायर एक्स, ये जो इक्वेशन है आपका ये जीरो के बराबर हो रहा है। तो दिस इक्वेशन इज मेनली यू कैन से दिस इक्वेशन इज डी टू एक्स बाई डी टी स्क्वायर प्लस ओमेगा स्क्वायर एक्स। ये इक्वेशन किसके, ये इक्वेशन रिप्रेजेंट कर रहा है किस चीज को? कि जब भी कोई एसएचएम का इक्वेशन होगा तो उसके डिफरेंशियल फॉर्म को हम ये बोलेंगे, दिस इज डिफरेंशियल इक्वेशन, दिस इज डिफरेंशियल इक्वेशन ऑफ एसएचएम। एसएचएम का ये डिफरेंशियल इक्वेशन है और इसका सॉल्यूशन क्या होगा तो उसके बारे में हम लोग आगे पढ़ेंगे कैसे हम सॉल्यूशन निकालते हैं इसका। बट दिस इज द फॉर्म ऑफ डिफरेंशियल इक्वेशन ऑफ द एसएचएम इक्वेशन। तो एसएचएम के लिए कंडीशन क्या हो गया कि एक्सलेशन जो है वो आपका माइनस ऑफ के बाय एम एक्स हो, जिसको हम लोग इस तरीके से बोलेंगे एक्सलेशन इज इक्वल टू माइनस ऑफ ओमेगा स्क्वायर एक्स, दिस वन ओनली। तो जब भी इस तरह का रिलेशन हो कि एक्सलेशन और विल बी इक्वल टू नेगेटिव ऑफ सम फंक्शन इट इज एंड देन डिस्प्लेसमेंट इफ इट इज, सो इसको देखते ही आपके दिमाग में बत्ती जलनी चाहिए कि ये तो एसएचएम है। और ये बत्ती जल जाएगी तभी आप डिफरेंशियल फॉर्मेट पे लाएंगे या इसको एसएचएम समझेंगे। सो दैट इज द थिंग यू हैव टू कीप इन माइंड। नेक्स्ट, अगर कोई भी फंक्शन आपको दिया हुआ है, कुछ इंपॉर्टेंट पॉइंट इसमें साइनोसोइडल वाले टर्म को हम लोग देख लेते हैं। तो कुछ इंपॉर्टेंट पॉइंट जो है उसको देख लेते हैं नेक्स्ट पॉइंट करके। फर्स्ट पॉइंट, अगर x दिया हुआ है आपको a साइन ऑफ ओमेगा टी, ठीक है, दिस इज द फॉर्मेट व्हाट यू कैन से। अगर हम इसको इसका डिफरेंशियल फॉर्मेट पे लाते हैं x का, अगर हम ऐसा इक्वेशन लिखते हैं a cos ऑफ ओमेगा टी इस फॉर्मेट पे, या अगर x आपको ऐसा दिया हुआ है कि a साइन ऑफ ओमेगा टी प्लस माइनस बी कॉस ओमेगा टी, इस तरह का अगर फंक्शन दिया हुआ है तो ये सारे के सारे जो है आपको जो इक्वेशंस है इसको हम बोलेंगे ये डिफरेंशियल फॉर्मेट में उस तरह का इक्वेशन बन जाएगा जो हमने ऊपर लिखा है देयरफॉर ये सारा का सारा इक्वेशन अगर इस फॉर्मेट पे होगा तो ये आपका एक तरह से हम कह सकते हैं कि ये रिप्रेजेंट कर रहा है किसको, एसएचएम को। इट रिप्रेजेंट, यहाँ पे लिख सकते हैं कि रिप्रेजेंट दे रिप्रेजेंट एसएचएम, यानी कि ए साइन ओमेगा टी फॉर्मेट में होगा तो वो एसएचएम करेगा, अगर ए कॉस ओमेगा टी वो एसएचएम करेगा, अगर ए साइन ओमेगा टी प्लस माइनस बी कॉस ओमेगा टी होगा वो भी एसएचएम करेगा। इस तरह के फॉर्म को हम लोग एसएचएम कहेंगे। दूसरा इंपॉर्टेंट पॉइंट है कि अगर आपको एक्स दिया हुआ है ए साइन स्क्वायर ओमेगा टी, इस तरह का फंक्शन है, या इसी को अगर हम साइन स्क्वायर फॉर्मेट को अगर हम लोग इसको ब्रेक कर लेते हैं कॉस के फॉर्मेट में तो इस तरह का भी दे सकता है a/2। साइन स्क्वायर को हमने ब्रेक कर लिया, इट इज 1 माइनस ऑफ कॉस 2 ओमेगा टी डिवाइडेड बाय 2 फॉर्मेट, सो दिस कुड बी द पॉसिबल। तो क्या ये एसएचएम को रिप्रेजेंट करेगा? बिल्कुल। यहाँ पे देखने के बाद आपको नहीं लग रहा होगा क्योंकि दिस इज साइन स्क्वायर ओमेगा टी, बट साइन स्क्वायर को हमने लीनियर फॉर्मेट में यहाँ पे ले आया, तो इसको आप ऐसे लिख सकते हैं, दिस इज a/2 माइनस ऑफ a/2 एंड देन इट इज कॉस ऑफ 2 ओमेगा टी, इस फॉर्मेट पे ये आ रहा है। तो इसमें हम ये चीज बोल सकते हैं कि ये जो है सो एसएचएम को रिप्रेजेंट कर रहा है, यानी कि ये फंक्शन जो है आपका एक्स जो है यहाँ पे, दिस ऑल्सो रिप्रेजेंट एसएचएम। कभी कभी क्वेश्चन एडवांस लेवल में पूछा गया है, दो तीन फंक्शन को जोड़ करके ऐड करके सब्ट्रैक्ट करके या डिफरेंट लिस्ट काइंड ऑफ क्वेश्चन बनाया गया है जिसमें ये रिप्रेजेंटेशन पूछा गया है, क्या ये एसएचएम करेगा? एसएचएम के लिए एक ही मात्र कंडीशन है कि वो इस डिफरेंशियल फॉर्मेट पे बिल्ड हो या एक्सलेशन ओमेगा स्क्वायर एक्स माइनस ऑफ ओमेगा स्क्वायर एक्स के तरफ बिल्ड हो जाए। तो अगर ऐसा बिल्ड हो जाता है तो आपका वो इक्वेशन एसएचएम को बिल्ड कर पाएगा, एसएचएम रिप्रेजेंट करेगा। तो यहाँ पे अगर हम इसको बोले तो दिस इज काइंड ऑफ this represent, here it is, this represents SHM। लेकिन इस SHM में आपका एम्पलीट्यूड क्या है? एम्पलीट्यूड इज द मैक्सिमम डिस्प्लेसमेंट फ्रॉम मीन पोजीशन। तो इस इक्वेशन में हमारा एम्पलीट्यूड क्या है? ए। इस इक्वेशन में एम्पलीट्यूड क्या है? ए। इस इक्वेशन में एम्पलीट्यूड क्या होगा? तो इसको आप आगे पढ़ेंगे या अगर आप जान रहे हैं, दिस इज इन द फॉर्म ऑफ ए स्क्वायर प्लस बी स्क्वायर अंडर रूट, ये इसका एम्पलीट्यूड होगा। तो इस इक्वेशन में क्या होगा एम्पलीट्यूड? इस इक्वेशन में रिप्रेजेंट द एसएचएम एंड इसका एम्पलीट्यूड क्या होगा? तो इस इक्वेशन में एम्पलीट्यूड हो जाएगा a/2। अब इस इक्वेशन में आपका मीन पोजीशन कहाँ पे है? ये मीन पोजीशन 0 पे है। इस पोजीशन में मीन पोजीशन कहाँ पे है? 0 पे है। इस पोजीशन में मीन पोजीशन कहाँ पे है? इस फंक्शन को आपको सॉल्व करके फिर समझना होगा। अगर हम ऐसे जस्ट बोल दें तो यहाँ पे अभी बोला नहीं जा सकता है, बट इसमें मीन पोजीशन का मतलब है कि at t is equal to 0 if you substitute our what is the x coming here, t0 sin 0, here t0 it is coming b, तो इसका मीन पोजीशन हम बोल सकते हैं कि b होगा। तो यानी इसका मीन पोजीशन b है, इसका मीन पोजीशन 0 है, इसका मीन पोजीशन cos ओमेगा t, इसका जो है x t पे जो है ये कहाँ पे है? एक्सट्रीम पे है। इस तरह से आप देखेंगे यहाँ पे अगर हम इसको 0 करते हैं साइनसोइडल 0 हो जाएगा, बट b cos ओमेगा टी यहाँ पे 0, तो ये b बच रहा है, यानी कि t0 पे ये कहाँ पे है? b पे है। तो इस तरह से आपको ये देखना होगा कि t0 पे ये कहाँ पे है, दैट इज द इनिशियल पोजीशन व्हाट वी कैन से, बट फॉर मीन पोजीशन हाउ यू विल अंडरस्टैंड दैट मीन पोजीशन इट इज, सो डिपेंडिंग अपॉन द साइनसोइडल फंक्शन, if it is sine function then it is its mean position is origin, if it is cos function then its mean position is if it is cos function then also mean position will be origin only, then it is start from extreme position. That is the thing you need to keep in mind. Now here amplitude we are having a/2 and the mean position what you can say here it is, its mean position is a/2, because once you are putting this to be 0, this function is 0, this sinusoidal function, so what is the x value coming here? It is 0. If we are putting here sinusoidal function 0, cosine function 0, so x is coming 0. So in above cases what you can say, all the equations is having mean position at origin, but here we are having, this is the mean position for this equation. Next we are having time period. So time period, how you can calculate? So time period will be it is 2 pi divided by omega. What is omega here? You can see coefficient of t, it is 2 omega. So what is the time period here you are having? It is 2 pi divided by 2 omega. So it will be pi by omega. So this is the time period. for this function. Likewise, the question can be asked to you that is it periodic, sorry, is it represent the SHM equation? Where is the mean position? What is the amplitude? Kind of question it is asked you. Okay, so next we are having that velocity and acceleration of SHM. Velocity and acceleration of SHM. So SHM के केस में आप velocity और acceleration को किस तरह से represent करेंगे? That we are going to see here. So this is velocity and acceleration of a particle executing SHM. Executing SHM. So whenever we have a particle in SHM, how you can write the velocity it's and how we can write the acceleration. So let us start with the function as x is equal to a sine of omega t, where a is your amplitude, a is the amplitude over here, and this is mean position of this function is, we know that it's a start from origin only, so this is the mean position. What is the velocity? It is dx by dt. So what is the differentiation of sine function here? It will be a sine, differentiation will be cos function. So what is the differentiation of sine? It will be cos of omega t, then omega t differentiation. So it will be omega. So how you can write the velocity? It is a omega cos of omega t. This is the velocity function here we are having. Can we write this function in sinusoidal function? Yes, you can write, because this is cos function. You can add sine function as plus theta value, that will be cos only. So we can write this function velocity as it is a omega, then we have sine, and then we have omega t plus of pi by 2, plus of pi by 2. So what you can see here, this plus of pi by 2. So sine pi by 2 plus theta, it is cos theta only. So what the function I have written here, it is the same thing what we are getting the result in case of velocity. But remember it, what you can see, get the idea from this relation is displacement. और अगर velocity को अगर हम लोग compare करें, तो displacement और velocity में, velocity SHM में pi by 2 से हमेशा lead करेगा. What is the maximum speed here you are getting? So maximum speed, you can say it will be amplitude of the velocity function. So maximum speed here will be a omega. This is a is amplitude, omega is frequency, angular frequency. So velocity हमेशा क्या होगा? हम लिख सकते हैं इस चीज को कि velocity leads displacement. Velocity leads displacement by pi by 2. कितना से लीड करेगा? pi by 2. ये कहां पे सही होगा? This is always true, always true in SHM. This is always true in SHM. ठीक है, आगे बढ़ते हैं. अब वेलोसिटी का जो हमने यहाँ पे फंक्शन आपको दिखाया है, this is actually function of time dependency velocity we are having. Once you change the time, it will change accordingly. So that is the thing you can understand. But if it is asked you that write the velocity of this SHM in terms of mean position x only, so how we can write that mean position? So velocity in terms of x, how you can write the velocity in terms of x? How we can write this? So very easy it is. How you can see this? How you can see this one? The velocity को जो आपने यहाँ लिखा है वो क्या है? a omega cos omega t. So यहाँ पे क्या है? a omega cos of omega t. यहाँ से आप ये चीज देख रहे हैं. This is the velocity, and from here you can see what will be velocity here. It is omega times of a omega cos omega t. I have written here. It is. So what you can write here? You can write this is, it is how you can change this cos function. You can write this cos function in terms of, can I write this velocity in terms of x? Yes. What is here from this relation? You can see what is the sine omega t here from this relation. So from position relation, you can see that what we have, x is equal to a sine of omega t. Exactly from here you can write sine of omega t is equal to x by a. So from here, if sine of omega t is this one, so what you can say, it will be cos of omega t. It will be 1 minus of sine square omega t. Simply it is. So what I can write here, it will be in root. So this is 1 minus of, it is x square by a square inside the root it is. So this you can write, it is a square minus of x square and then divided by a only. So this term you can replace here with the cos function. So it will be a omega. Then cos omega t can be replaced as a square minus of x square and then divided by a. So a get cancel out. So this velocity you can write here it is. This velocity will be, it is omega times a square minus of x square. So this is the velocity you are having. This velocity is for what? This is the velocity of SHM as a function of x. So this is function of x only. You can see here at x is equal to 0, x is equal to 0. If I'll say that at x is equal to 0, what does it mean? It means mean position where the x is 0. If you put x is 0 at mean position, this x will be 0. So what the we have velocity? It is v max. What it is? A omega. What it is? A omega. Now, if you suppose to put the x value as a, so at x is equal to a, at x is equal, when x is equal to a, this is called extreme position. Extreme position. So when it is at extreme position, when the particle is at extreme position in case of SHM, this a square minus a square will be 0. So what the velocity you are having? 0. So whenever we are having 0 velocity at extreme position, if it is 0 at extreme position, no velocity speed it is. So you can say the kinetic energy will be also 0. I'm not talking about kinetic energy right now. I'll talk about in energy segment. But just now I'm just giving you a hint that if the speed is 0, that you need to understand the kinetic energy will be 0. So this is the position where we are having kinetic energy 0. It is at extreme position only. Extreme position only. So this is the thing you have to keep in mind, that how to write the velocity as function of x, how to write the velocity as function of t, and how you can correlate over there. How you can correlate over there. So that is the thing you have to keep in mind. Okay. So next point, we are having acceleration. Acceleration in case of SHM. How you can write the acceleration? Acceleration is dv by dt. Acceleration is called dv by dt. So whenever we write acceleration as dv by dt, once you know that what is the velocity here we are having a omega, then cos of omega t. This is the velocity we are having. Once you differentiate this relation, you'll be getting acceleration only. So a omega is the constant part here we are having. So a omega will be constant part. So differentiation of, here it is cos of omega t. So once you differentiate this cos function, it will be a omega. Then differentiation of cos function will be minus of sine of omega t. Then again it will be omega. So what you can write over here, it is minus of a omega square. Then we have sine of omega t. So this is in the form of what you can say acceleration. So acceleration, what we have written here, you can see this a sine of omega t. We know it as x is equal to a sine of omega t. This was the x value, x sine of omega t. Then we have velocity as a cos a omega cos omega t. So this is the x value, displacement value, and this is the velocity value. And what we are having the acceleration, this acceleration is a omega square sine of omega t. So what you can write over here, it is a sine omega t can be considered to be the displacement of the SHM. Here it is. So यहाँ पे आप acceleration को लिख सकते हैं. This is omega square of x. So this is the function what we are having, acceleration as function of x here, acceleration and x relation, position relation. लेकिन अगर इसको आप टाइम के फंक्शन में ही लिखना चाहें एक्सलेशन को, तो यहाँ पे हम लोग इसको भी लिख सकते हैं. दिस इज व्हाट यू कैन राइट ओवर हियर. इट इज a omega square then sin omega t plus of pi sin pi plus theta, it is minus sin theta. So here it is minus sin theta. a omega square, the constant part it is I am considering here. Then sine omega t plus phi, sine omega t plus phi will be in third quadrant, and in third quadrant sine will be negative only. So here you can have this acceleration. From this acceleration relation, you can see that this is what we are having the acceleration, and this is the velocity what we are having in sine function. It was a omega, then sine of value it is omega t plus of pi by 2. So here this velocity, you can see that velocity is leading the displacement by pi by 2, and again you can see this acceleration is leading the velocity by pi by 2, because the difference between the phase difference of velocity and acceleration is pi by 2 only. So what you can say in case of SHM, it is acceleration leads. Acceleration leads. So you can say the acceleration leads the velocity by pi by 2. That is the thing we can say here. So that is acceleration leads velocity. Acceleration leads velocity by pi by 2. That's it. So in before case, we have seen that velocity was leading with the position displacement over there by pi by 2. Here you can see that acceleration is leading by pi by 2. Pi by 2 it is. Also, one thing you can relate with the displacement and the acceleration, that displacement is happening pi by 2. So what does it mean that, sorry, if you compare acceleration with the displacement, so what the displacement is having the phase and the acceleration is having the phase, there is phase difference of pi there. So pi phase difference means what? Means that if displacement is happening this direction, the acceleration will be in this direction. So this is the direction of acceleration and this is the direction of displacement. That is the meaning of pi here. So once it is in SHM, that you have to understand that acceleration will be always opposing behavior of the displacement. That is called SHM. That is called SHM. This is the SHM only. Now what you have seen that acceleration relation, how we can write acceleration in terms of x function, and how we can write the acceleration in terms of time function, how you can relate velocity, and how you can write the x displacement in case of SHM. So these are the basic concept, and on the basis of these basic concept you can have JMN kind of question you can see there. Now what we'll go for the next is, this is what you can say, you can write the all chart over there to remember it, how you can remember this. Let's see the next chart it is. So this kind of chart you can make over there for simplification point of view. I'm writing here. So this I'm writing parameter. This parameter is what you can say here, it is this displacement only, and this first parameter I'm writing here displacement. So it is displacement. Then we have the variation of with time it is. So it is variation with time. With time it is. How it is varying with time? This is the function here we'll be getting. Then velocity, we can write this chart. This chart I'm writing for so that it will be there in your mind. You can remember it. So if just looking to the chart only, you can go for it. Then next you are having that acceleration. So this is displacement function I have written here. X is equal to a sine of omega t, this one. Then velocity function, it will be a omega and then cos of omega t, this only. And then acceleration relation, it is minus of a omega square, then it will be sine of omega t. So this is the acceleration, velocity, displacement, velocity, and acceleration relation. Now variation with position, if I want to write it as, then variation with position, or you can write this variation with position. So you can write this variation with position. It is x is function of time only, so we are not writing this one as it is x only, and this time function here we are having. So if this function is not, we can write here it is. But in terms of velocity and position relation, we are having that velocity is equal to, it is it will be omega times of a square and minus of x square. This is the thing you'll be getting in plus and minus format. Why plus and minus format? because one side, if it will be taken as plus side, then the other side, opposite side, will be minus side. That is what it is, plus and minus. Then we are having this acceleration is equal to minus of omega square x. Then we are having the next chart. It is at mean position. At mean position, I'm writing all the details whatever I have discussed here. So this x is equal to 0. Here it is. What is the this, you can say, velocity at the mean position? It will be, so velocity at the mean position, it will be v is equal to, it is plus minus of omega. This is the velocity. I can write it is plus minus of omega. And what will be the acceleration at mean position? It will be 0. So at mean position, we have acceleration 0, displacement 0, but still we are having the velocity over there, so that we'll be having the kinetic energy. Now you can see the another chart here. It is at extreme position. At extreme position, if I'll go for this one. So at extreme position, what is the displacement? It will be plus or minus. If it is right side of the mean position, it will be plus. If it is left side of the mean position, it will be minus. At extreme position, we don't have any velocity, because you know that if you put here x0, x is equal to a, here it will be 0 only. So at extreme position, we have velocity 0. And at extreme position, we have acceleration. This you can say it will be omega square times of x. X will be a only there, a. And when it is minus, here it is written already. So minus will become plus and plus will become minus. So this sign here I am writing on the basis of plus will be what you can say, if it is right side of the mean position, and minus it will be, sorry, what I have written here is should be opposite in direction. First it will be that minus and then plus. So it is minus, then it will be plus. So it is omega square and a. Minus sign will be at the right side of the mean position, and the plus sign will be at the left side of the mean position. So this is the thing you have to keep in mind. Everything I have discussed here. And on the mean position, extreme position, variation with time, variation with position, this you can read. Another thing, this also you can go for that. What is the at t is equal to 0? At t is equal to 0. At t0 means it will be initial time, you can say. So at t0, what is the displacement here? You can see it will be at mean position. At t0, if you go for the velocity, what will be the velocity at t0? It will be velocity at t is equal to 0. It is a omega. And at t is equal to 0, what will be the acceleration? It will be 0. So at t0, we have displacement 0. And t0 means, you can see one case here, it is what we are having the mean position only, but we can't say exactly at mean position. I have taken there that x is equal to 0. So x is equal to 0 is something, but at t is equal to 0 is something different from the mean position. You can't say always that wherever we are having x is equal to 0, t will be 0 only. It is not like that. Maybe that you will be having different kind of question in that scenario, that it is somewhere else and that position is considered to be the initial time over there for the motion kind. So ये चीज आपके दिमाग में रहना चाहिए कि कौन सा मोशन दिया हुआ है, कहां से दिया हुआ है, क्या क्वेश्चन को लिखा जाए, ये सारा चीज आपका जो है क्वेश्चन को आसान कर देगा. टू अंडरस्टैंड इट इज वेरी इजीली, यू कैन अंडरस्टैंड. नाउ नेक्स्ट वी आर हैविंग द graph representation. How we can represent the graph of SHM if it is given to you, xt graph, if it is vt graph, and if it is at graph. So next segment we are having graph. So graphical representation SHM. So first we are looking for position time graph. Position time graph. So this is this first graph we are having. This is position time graph. Position time graph means it is xt graph. So what the x-axis we are having, let's say it is this. I'm considering this y-axis your position and x-axis your time graph, and the graph is starting from mean position sinusoidal function. It will be like this kind of graph will be having. So this is your mean extreme position. What we are having, this is the amplitude in positive direction we are having, and then we are having the negative direction, what will be the maximum displacement from that? This one is the negative displacement. Here it is plus a, this we can say, and here it is minus of a. And here, if I'll write the time, because of the time, this is half time period, so it is t by 2. Here it will be t, and here it will be 3t by 2. 3t by 2. So likewise, the time period rotates over there. Here it will be 2t. So this way it will be. Then we have equation of this graph is xt graph. Here you can see that everything I have mentioned, time and the position it is. Now you can see the what will be the graph of velocity and time graph on the same parameter I wanted to write. Here it is. So this one is time axis and this is velocity axis. And velocity axis, you have seen that it is what it is, cosine function. So cosine function will start from mean position or extreme position. So of course it will start from extreme position only. So at t is equal to 0, is there any velocity? Of course it will be. That also I have written here in chart. You can see here at t0, what is the velocity we are having? At t0 we are having a omega velocity, a omega. So the graph is starting from y positive direction. So here let's suppose I am considering here it is. So it is plus of a omega. And from here the graph will start and it will come to the somewhere it is, when it will be 0, it will be 0. This is the position where we are having the maximum value it is. So it will come the graph, you can have this kind of graph, it will be cosine function graph it is. So this kind of graph we are having. I'm making this graph will be like this. This kind of graph you can see here it is. So this is made somewhat extended. Here it is. This graph is like this will be the graph if I'm considering here a omega, and then again it will be downside somewhere it is. Again it will go till that height a omega, and again it will come like this. It will be having this kind of graph. So this kind of graph is there. So whenever it is coming down here, it is maximum, it is minus of a omega. Where it is coming 0, this time here you can see. So this is the t by 2 time. Here we are having t by 2. Here it is. So t by 2, this is coming is at this position, extreme position. Here it is there. So this is the midpoint of t by 2. It will be t by 4 here. Again, it is at t position. There it is. This t position here it is. So again, it is 3t by 4. So here it is 3t by 4. And here this time we are having, this time is what you can say here. It is at t position where it should be. It should be at down. It should be at down. So it is there on this function here. So this is there at what I have written here. This is t. This is t by 2 position. This is t only. And then we have here it is 3t by 2. That's it only I have written here. This. So till 3 by 2 I am drawing here. Accordingly, the graph you can understand that this graph is. Next we are having the graph between acceleration and time graph. So in the same time interval, if I'll write there, so this is the acceleration and time graph. This is time axis and this is acceleration axis. And the acceleration is starting, you can see it will be from positive direction or negative because of this function. Acceleration is written to be, this is minus of a omega square, and then sine, it is omega t, like this function it is. So this function we are having sine function only, but it is starting from negative. It start from negative zone, so it will be having, this is what we are having, this time function. And then this time function. So this is t by 2 position, this is t position, and again it is 3t by 2 position. So it is starting from sinusoidal function it will be, but it will start from the this way, it will start this way, it will start like this it is, and again it will go like this way it will be. So this kind of function, if it is there, you can understand this is the acceleration time graph where it will be the maximum value, that is called the amplitude part of it. So it will be minus of a omega square, and in numerator, in positive segment here, you can see here, it will be, this is plus of a omega square. So this is the acceleration time graph. You can understand that there it is. Now what we have, there is one relation that sometimes it is asked you that what is the relation between, next we are having, draw the graph of velocity versus displacement graph in SHM, in SHM. So this is very important. This question asked in advance also, JMain also, how you can draw the graph between velocity and the displacement. So we know that velocity is equal to, this is omega times root under a square minus of x square. This relation we know. So from here you can see this is v square and is equal to omega square a square. Then it is minus of omega square x square. And we are looking to have that relation between v and x. So v square plus omega square x square can be written like this is omega square a square. Now you can see in the next step it is v square by, it is a square omega square. Then we are having this, it will be x square by omega square get cancelled out. So here it is a square, and this is nothing but 1 only. So this is the thing you can see here. This relation is a standard form of ellipse. It is elliptical in nature. So elliptical in nature means if you draw the velocity and position graph, why? Because I have written elliptical, that we know that it is x square by a square plus y square by v square is equal to 1. This must have you learned in the ellipse relation. It is x, this a is major axis, semi-major axis, and b is semi-minor axis. It is, then accordingly you can write. So if I'll draw the graph of ellipse here, let's suppose this kind of graph, if it is there. So x-axis we are having position and y-axis we are having velocity. So what is on x-axis we are having here? It is, from this you can see this will be the amplitude on x-axis, either plus, right side we have plus a, left side we have minus a. And what is the here intercept on velocity axis? You can see it is a omega only. So this side we have a omega plus this side, and this side we have a omega minus. So likewise, you can understand, and this is the graph of this ellipse will be this way. You can write it is x square by a square plus this is y square by b square. So it is a times of omega, a omega times square, and this is 1. So this is the equation of this velocity and position graph. You can have this one. This way you can write the graph. It is okay. Now we have equation of SHM in different situations. So this is also very important, that in different situation, how you can draw the equation of SHM. So this is equation of SHM in different situation, different situation, different situation. So this is what it is. Let's suppose I am writing that this displacement of the SHM is x is equal to a sine of omega t and plus of phi here, where phi is initial phase. This is called initial phase. When t is equal to 0, this is the phase only. So it is called initial phase. Initial phase means angular position it is. So once you can see the graph in equation of SHM in different situation, how you can write over there, what are the equation you need to think over there. So if it is like this is the normal line I am considering here, and here is the position which is considered to be mean position. So then let's suppose this consideration of a mean position line here I am considering here. So this position we are having x is equal to 0, and if this block is there and this object is there, and if it is moving with this equation format, so how you can see the equation? So if it is moving in this direction, right direction, so what we can say from mean position if it is, so we can start with x is equal to a sine of omega t. This is the equation. Now when it will be at extreme position, at this position, so at this position we are having x is equal to plus a, and here this you can say that if it is moving this side, then we can start with x is equal to a and then cos of omega t. This is at extreme position. So this is the thing you need to remember. And when it is moving this side, left hand side, then you should start with x is equal to minus of a sine of omega t. This is the thing you have to remember. And when it is at the left hand side extreme position, this position, and so x will be here minus of a. So this is what you can say, it is x is equal to, it is moving from extreme but in opposite direction. So it is minus of a cos of omega t. This we can write over here it is. So this is the thing you can understand, that extreme position we are having x is equal to like this a cos omega t and x is equal to plus a. And left side of the mean position it is x is equal to minus a and x is equal to minus a cos omega t. You can understand here. Next, if I'll think about the phase difference over here, it is, so let's suppose the particle is starting from this position and it is having phi 0 here. It is phi 0 means phase difference 0 because it is starting from initial point and I'm considering there is phase, initial phase is 0 over there. So it is start from this position. Once it is reaching to the position where we are having, it is mean, it x is equal to, let's suppose a by 2 position. So when it is a by 2, the phase difference will be, you can put over there, this phase difference will be, here we have, it is pi by 6. So how we can get this information? So you can write x as a by 2, a get cancelled, sine theta is half, so it is half means it will be 30 degrees. So here it is 30 degrees. So at that at this position, when the phase difference is pi by 6, you should understand the position is a by 2, mean position it is. Mean position mean amplitude, half of the amplitude it is. Now it is moving in the same manner and it is reaching to the extreme position. And again, its path is getting, its direction is getting reversed. Let's suppose when it is getting reversed, so by that time, its phase difference will be what you can say when it is reaching to the maximum position. So you can see here at maximum position, x is equal to a only. So sine theta here, it will be pi by 2. So what you can say phase difference here, it will be pi by 2. Again, when it is reaching to the same position what it was the time of going 8 by 2 direction in this direction, and when it is coming back direction, by that time what will be the phase difference over here, it will be. So what you can add here, it is, this is in this direction, positive direction, and now this is coming in towards mean position. It is away from mean position, it is towards mean position. So it will be 5 pi by 6. Here it is. So when it is coming to the position of phase difference 0, when it is reaching at this position, so phase difference is what you can say with respect to the initial phase, it will be, here it is pi value, pi radian. And when it is reaching to this extreme, this half position of this one, left hand side we are having, when it is reaching to this position, then it at this position, you can see here, the phase difference will be, it is 7 pi by 6, 7 pi by 6. Again, when it is reaching to the extreme position and it is returning back to the original position. So you can see here, at this position, we are having phi is equal to 3 pi by 2, 3 pi by 2. And again, when it is crossing this position, so it will be, phase difference will be here. Here phase will be, it is 11 by 6 pi. How I am writing this one, you can have the equation of SHM and you substitute the displacement over there, you can get the phase difference over there with displacement putting value. X is equal to a, x is equal to a by 2, x is equal to minus a, x is equal to plus a. Likewise, you can get the phase difference, phase over there. So at this position, when again it is coming, sorry. So at this position, we are having phi is equal to 2 pi, 2 pi. So it is started from this position A, this position, mean position, when phase was 0 only. And again, when it is reaching to the same phase, its phase now became 2 pi. So what you can get from this diagram, it is, why I have drawn this diagram is, each and everything you can correlate with the phase and the position you can by yourself only, so that there won't be any kind of confusion to understand this diagram it is. Okay. So here one can imagine the things that from this diagram only, that if it is asked you phase difference between two particles. Let's suppose two particles at a by 2 from mean position. If it is said to you this mean position moving opposite to each other, will be what? So in this case, what you can say, phase difference between two particles at a by 2, one is moving right side and another is moving left side. We are having this phase angle here. It is one is pi/6, another is pi/6. At the same position, one is moving left hand side, another is moving right hand side. So one is going right hand side and another is going left hand side. So we can say the phase difference here by just looking to this diagram only, that what will be the phase difference here. It will be 5 pi/6 minus of pi/6. So this is as much easy kind of question it will be. So you can see, I think you can understand that why this diagram I have made. This is easier for you to understand. Many questions you can solve from this diagram only. Okay. Now, whatever the things we have done is we have discussed mainly in SHM, that equation of SHM, velocity of SHM, acceleration of SHM, mean position, extreme position, how we can write how we can write velocity as a function of time, as a function of x, it is acceleration, everything we have discussed. Now we have to learn the energy concept in SHM. Okay, so this is energy in SHM. How you can relate energy in SHM. So whenever energy in SHM is there, this chart you have to remember. What I am going to write is, this is very important chart, that whenever we have oscillating particle, it is in SHM. So you have to remember this chart. This is very important. So if it is there mentioned that this is oscillating quantity, I am writing oscillating quantity, this wait. Here we are having oscillating quantity. If it is displacement, if it is kinetic energy, if it is potential energy, if it is kinetic energy and minus potential energy, or potential energy minus kinetic energy, or maybe total energy. These are the total energy. These are the parameter which I have written here, 1, 2, and 3, and then 4, and then 5. These are the parameter which you can understand that oscillating quantity over there. So what is the time period? If I'll consider the time period here, this is time period, and this is frequency. This you will learn, and you can understand from the equation itself. So for displacement, I'm writing time period to be t and frequency to be f. Then what will be the kinetic energy time period? It will be t/2. It will be twice of frequency. If time period is getting half, frequency will be doubled. If this is potential energy will be having time period t/2, it will be frequency will be doubled. Then the kinetic energy minus of potential energy, if it is, then modulus of this one will be, whenever this is considered to be difference between this one. So by that time you will be having time period as t/4, and the frequency will be 4 times. And for this total energy, what will be the time period? It is infinity, and for this frequency will be 0. So these are the things you can remember, and many questions you can solve from this only, that this is the chart between displacement, kinetic energy, potential energy, difference between the energy and the total energy, time period, and the oscillation. What is that one? Next, kinetic energy, one can write in terms of this way. You can write the kinetic energy. First, I'm writing kinetic energy. So how you can write kinetic energy in SHM? I'm not going in deep, just revising only. So kinetic energy, we know that it is kinetic energy is half m then v square, and we know it is in two format. One is omega a square minus of x square, and another is v is equal to it is a omega and then cos omega t. This one we know. If the displacement is x sin omega t, then so here you can write kinetic energy to be half m. V square can be written like omega square, then a square minus of x square. This one is the v square here. From this relation, you can relate v square will be this one. So this is the kinetic energy. You can remember what will be the kinetic energy maximum here. One can say what will be the maximum kinetic energy. So x will be 0. Where x will be 0, mean position. So here you are having half m omega square a squares. So this is the maximum energy and this is the total energy also there, where it will be at mean position. At mean position. So this is the thing you have to remember. It is mean position. Kinetic energy maximum, it is half m omega square and then a square. That you can remember. So next kinetic energy will be minimum, where it will be. So if I'll say minimum, you can substitute this x to be a amplitude here it is. So at extreme position, it will be 0. So this will be 0. And by that time, this kinetic energy is 0 means it will be at extreme position at x is equal to a plus minus a. So this is at extreme position. Extreme position. So where you can say that kinetic energy will be kinetic energy will be minimum, it will be minimum at extreme position. Where it will be maximum, it will be maximum at mean position. And in general, it is function of x. You can write like this. This is the function of x. You can write the function of t also. So kinetic energy you can write in this form also, half m and then v square. V square will be a square omega square and then it is cos square omega t. This also you can write. This is the function of t. Function of t, it is written to you. So when you have this kind of function, it will be, that is why I have taken here kinetic energy time period will be t by 2. Once you solve, once you see this one, this function here it is. So this function will be having time period t by 2. That is the thing here you can get. Kinetic energy time period will be t by 2. So the frequency will be twice of the frequency of the displacement. It will be 2m. Now you can write kinetic energy average. So average kinetic energy. So the function, these are the constant term which is multiplied with the cos square omega t, and we know that cos square average value will be half. It is in one time period. So it will be 1 by 4 m a square omega square. So this is the kinetic energy of average kinetic energy. You can say this will be. So I have written here everything about the kinetic energy, average kinetic energy, function of time, kinetic energy minimum, kinetic energy maximum, kinetic energy function of x. This one. So by this way, you can remember what are the kinetic energy in SHM, everything you can get off. Next, you have potential energy. The next potential energy. So potential energy, the first format, what we are having potential energy in case of SHM, it is half m omega square x square. This is the potential energy. And we know x, you can write like a sine of omega t, a sine of omega t. So what we are having, this is function of x. This you can write half m omega square. And then x can be written like this is a square. And then it is sine square omega t. Here also this function is sine square format. Their kinetic energy was cos square format. So what the average value you will be getting here also we are having half average value. So you can say that potential energy, this if I'll go for maximum potential energy, so this x will be maximum at the amplitude position. So it is half m omega square a square. And this is nothing but the total energy where it is at extreme position. At extreme position. At extreme position, we have kinetic energy 0, but potential energy maximum over there, that is total energy. Then potential energy minimum. minimum it will be at a mean position, x will be 0, so it will be 0, and that is what you can say at mean position. At mean position it will be 0. Now you can see here what will be the average potential energy. So potential energy average will be, it is sine square function average is half only, so it will be 1 by 4 m omega square a square. So this is the average value of the potential energy. So potential energy average, minimum, maximum, function of t. This I have written here. This is function of t only, and this is function of x. This one. So everything all about the function of x, function of t, maximum, minimum, and average. This is all about the potential energy of SHM. Sometimes if it is asked you what is the total energy, total energy. So you can say total energy. This total energy will be kinetic energy plus potential energy. What is kinetic energy? It is half m omega square. Then we have a square minus of x square. This is the kinetic energy where we are having. Then potential energy half m omega square x square. Once you remove this bracket, x square minus term, and this term will get cancelled out. So this is half m omega square a square. This is the total energy what we are having. This is total energy. Total energy what we are having. That is, whenever particle is oscillating SHM, by that condition, this energy conservation will valid. So wherever you will go from mean position, this is, let's suppose mean position, this is your extreme position, and this is also extreme position. So if you are moving from mean to extreme, so what the energy here, mean position, it is total energy. What the mean position, extreme position energy, total energy. In between, if you are having, so here we are having kinetic energy maximum at mean position and the potential energy minimum. Here we are having kinetic energy minimum, and that is 0, and here we are having potential energy maximum, and that is total energy. In between, if you are getting, you are having potential energy plus kinetic energy, both you are having. Sometimes it is there that at mean position no potential energy is 0. So if it is mentioned to you in the question that there is some potential energy at the mean position, then only we will consider that one. Else we understand that potential energy at the mean position will be 0 only. That you have to keep in mind. Now both kinetic energy and what you can see here, kinetic energy and potential energy as a function of, if you say there, it is function of x square. So if you want to draw the graph of kinetic energy and potential energy versus x, so kinetic energy is half m omega square, and it is a square minus of x square, and potential energy is, it is half m omega square x square. So this is x square negative, so it will concave downward, and this is x square positive, so it will be concave upward. So this kind of graph you'll be having. If this is the combined graph I am drawing here, this is combined graph it is. So on y-axis we are having total energy, and this is the x-axis we are having displacement. So this kind of graph you'll be getting here. This is what it is called. This graph is called potential energy. Why? Because this is x square some coefficient it is. So it is concave upward graph. So this graph is for potential energy. And in the same manner, if you'll go for the other graph, this will be negative of x square format. So I'm starting in the same way where it is in this projection I'm considering, so that it will be, this is what I've taken this position to be the maximum, and energy over here it is maximum energy. So at x is equal to a, we are having maximum potential energy. At x is equal to minus a, here also we are having maximum potential energy, and that energy will be on a y-axis if we go for. So this is the total energy we are having. This is what it is. At this position it is half m omega square a square. At this position we are having this energy. So this is your, this energy is your total energy. Total energy. Now in the same way you can draw the graph of this way as a the kinetic energy graph. It will be like this. It will be like this. So when it is at mean position, you can see here at this position we are having the maximum. This is the graph of kinetic energy, and this is the graph of potential energy. And this, wherever you'll go between, here it is both kinetic energy and potential energy are getting clash over here. That means both are having the same position. They are having the same position. The kinetic energy and potential energy are equal at this instant. Here also we are having kinetic energy and potential energy equal. So this is the thing here at extreme position we are having where the kinetic energy and potential energy will be equal. We'll just discuss where we are having potential energy as kinetic energy. So kinetic energy we are having half m omega square and then a square minus of x square. This is kinetic energy. And what is potential energy? Half m omega square and x square. So once you see here half m omega square, it is common cut, it will be. So we are having 2x square as a square. So what is the x value we will be getting here? It is plus minus of a by root 2. So what the x value we are getting here? It is this position, the x value you can write here, it is this position, it is x is equal to minus of a by root 2, and here you can see this position we are having x is equal to plus of a by root 2. So at this position we are having same kinetic energy and potential energy, so you can get, so wherever you will go on the curve, total energy will be always constant, and it will be half m omega square a square always, half m omega square a square always. So this is the total energy you will be getting every time any point if you go on the SHM, if it is performing from mean position, extreme position, or between anywhere position, this energy will be constant everywhere. Now the second part of the question, second part here, you need to understand that where the we have potential energy and kinetic energy equal. By that time, what is the time in case of that? What you can say? Time period it will be. So when we are having this x is equal to plus minus a by root 2, that position we are having the kinetic energy potential energy equal. So we can start with x is equal to a sine of omega t. This is the equation of general equation of the displacement SHM. Then x will be where x will be kinetic energy and potential energy same. So x will be plus a by 2 or minus a by 2. I am considering plus a by root 2. So this position if I am considering here, so this will be a sine of omega t. Here it is. So a get cancel out. So what you can see here, sine theta is 1 by root 2. It means omega t is equal to pi by 4. So it means what I can write, omega means it is 2 pi by t. 2 pi by t into t, it is pi by 4. So one you can see here, this t will be, it is time period divided by 8. So that means the time what we are getting here, it is time period divided by 8. At this time, we have the kinetic energy as potential energy. This is the kinetic energy is equal to potential energy. Position time it is, and this is the position where we are having kinetic energy as potential energy. I hope it is easy for you to understand that this kinetic energy and potential energy graph it is. So this is all about the kinetic energy and potential energy relation in case of oscillation SHM it is. So these are the major topics which I covered for the JEE point of view, and some topic may be helpful for you in JEE Advanced also. So this is the thing it is. Now the next topic we are having is that simple pendulum. So in this case we are having the next topic, simple pendulum. So in case of simple pendulum, we know that simple pendulum concept, that time period of the simple pendulum, oscillation of simple pendulum when it is L is the length given to you, and angular displacement will be there, some angular small displacement is there. So the time period of simple pendulum, we know it is 2 pi root under L by G, where L is the length and G is the acceleration due to gravity. That you need to keep in mind. Now, if there will be some variation in the length and G, that how time period changes. So the first factor I'm considering that if length is changed, if, if length is, if L is changed, L is changed means we are considering here G to be constant. So what is the fractional error in the time period it is? So fractional error it will be delta T divided by T, and this is equal to half delta L by L. How I have written like this? So you can see time period is directly proportional to L to the power half. And in case of fractional error, you must have learned that this is L to the power half format. So what is the fractional error in the time period? We can write like this. It is half times delta L by L. So this is the thing you know that. The second thing we are having, if gravity G is changed. So whenever we have G changes over there, G changing case. So in that case, what you can say, L is constant. So what is the time period we are having? That time period is directly proportional to G to the power of minus half. So here we can say that what is the fractional error in the time period? It will be minus of half, then delta G divided by G. Here it is. So this is the error in measurement of the relative error in the time period measurement. Likewise, it is. So delta T is the, what you can say, that minimum reading of the time period over there, and T is the time period, delta G is that only. So sometimes it is ask you some G value. If it is both changes, in that case, what you will do? If L and G both changes, L and G both changes. So in that case, what you can do here, that time period we are having 2 pi root under L by G. Okay. So on the basis of time period is 2 pi root under L by G. Once you are squaring this one, so it will be T square, and it is 4 pi square times of L by G. Now 4 pi square is constant term. So you can relate the time period and length and G only. So what we can say here, it is relative error in this one. It will be 2 times of delta T divided by T. It will be equal to delta L by L plus delta G by G. So this type of question is asked already, that when some time period changes, relative error in time period is given to you, relative error in length, what will be the relative error in G? So what will be the relative error in G? Here you can calculate. This is the relative error in G, this is the relative error in length, and this is the relative error in time period. So this kind of question already asked in JMN, you can go through it and you can solve by your own. That is the thing. It is with time period related things, you have to remember this one. Now we have oscillation of springs. So next topic we are having oscillation of spring. Oscillation of spring. So whenever a spring and block system is attached over there, so this thing you can